Dear Dr. Wu, this is Fanjing, and here's my project presentation for cross-wireless communication. My project title is Performance Analysis of Error Control Coding and Improved ARQ Schemes. My project is focused on the error recovery schemes. Based on the mechanism, there are mainly two error recovery schemes: forward error coding (FEC) and ARQ. For the FEC, some schemes have been covered in channel coding. For ARQ, so it's not covered in class. I think it's important because it's complementary to the FEC, so I added this part to my project. And here is outline of this presentation. There are 4 parts. First is the problem on the study. First problem is how to use the 1511 Hamming code to design the whole data transmission process. In this project, I mainly focus on the 1511 Hamming code and use it to design the whole data transmission process. The second problem is to derive the mathematical throughput of the 2 advanced ARQ schemes. In this project, I introduced 2 advanced ARQ schemes, and to simulate the throughput of the ARQ, it is essential to have a deep understanding for its mathematical expression. Then there are existing approaches. For problem 1, as I mentioned, I will use the 1511 Hamming code and to design my project. Its principle is almost the same to the 74 Hamming code that has been covered in class, so I just use it as an instance. For the encoding, the 4-bit source code generates the redundancy bits from the generation matrix G. G is organized by a unit matrix and another matrix called Q. And for decoding part, I will use you will use this supervising matrix called H to detect and recover the error bits. H is derived from these functions. And one should be known as the minimum Hamming distance of 1511 Hamming code is 3, is the same as the 74 code. So it's just able to detect a 2-bit error and recover a 1-bit error. Here is the matrix G and H that will be used in my project. They share the same pattern to the ones of the 7-core Hamming code. And here is the whole channel coding process I designed for my project. And first is the source code. I will use the random int function in MATLAB to generate the 11-bit random sequence as source code. And then I skip the source coding part because I think it's makes no sense to my project. And for the channel coding and decoding, I will use the 1511 Hamming code just as described. For the modulation and demodulation, I will use the BPSK. And for the channel transmission, I will use the AWGN. This is a function in MATLAB to add the noise to signal. You can adjust the SNR inside the function. All the details and parameters I have shown in my report and project and coding, so I just skip it. Then is the existing approach for problem 2. As I mentioned, I introduced 2 advanced schemes in my project. First is the go-back-n ARQ scheme with SR in intra-block, GBN SR for short. In this scheme, the sender delays any decision regarding the packets of a block, which consists of multiple packets, until all the acknowledgements for each packet of the block have been received. The sender retransmits blocks including multiple copies of only the requested packet after it receives a retransmission request. It is well known that the throughput performance of the of this can be significantly improved at high error rates. When the sender receives a retransmission request, the next step is to retransmit blocks that include only the requested packets. As a result, the size of the block varies from retransmission to retransmission. And the second one is called copy transmission. And actually, they are related. These two schemes are related, and the difference is in this scheme, the number of the transmission of the frame is limited, and the receiver will accept the frame when it reaches the upper bound of the transmission time, regardless of its correction. These schemes make it possible and reasonable to set the upper bound threshold on the transmission time. And another difference is at every retransmission, you could see from the picture, it will be multiple. It will have multiple copies, and because of these two differences, two more parameters will be introduced in these schemes. Here is a performance variation of existing approaches. First is the waveforms of every step, every transmission step with the SNI 10, and in my report I'll set the SNI 5 and 1 for comparison and evaluate and analysis. And here is a simulation result for 1-bit error. You can see here is a 1-bit error at the 8th bit, and after decoding, it is efficient to recover that. Here's simulation result for no error. And here is the throughput for the two ARQ schemes, and for contrast I set all the parameters the same, and for this one, for second schemes, there are two more parameters, and as I have described it. And his conclusion, for the 1511 Hamming code, the Hamming distance is 3, then it's just able to detect a 2-bit error and recover 1-bit error. And for the error of more than 2-bit is useless, and more advanced schemes are needed. From a simulation of my project, 1511 Hamming code is quite efficient for recovering 1-bit error. The higher of the SNR, the higher the error rate. That's because the higher of the SNR, more bits will be distorted and become an error bit. So when there are more than 2-bit error in a sequence, the 1511 Hamming code is not able to cover that. And for the ARQ schemes, in this project, two relative advanced schemes are introduced. They have much higher throughput than the three basic ARQ schemes: stop and wait, go back in, and selective repeat. From the result, we could see their throughput almost the same when the bit error rate is low. Even the GBNSR is more stable. When the bit error rate is high, the throughput of the GBNSR drops more faster than the copy transmission. That's because when the bit error rate is high, you keep retransmission, you just add more congestion to the channel, and set the bound of the transmission will be helpful to release the channel. Here then is my demo. First is for my channel coding, and just run it. Here is the waveform of every steps, and let me see. Oh, the SNI is 10. And here's my result. You can see there's no error. I can try again, but it's not guaranteed there will be an error. It depends. Let me try again. No, still no. Then I simulate the throughput of the two ARQ schemes. I'm sorry. First is GBNSR, and for this one it's a copy transmission. Okay, that's my presentation, and this is my last course UF, and best wishes. Thank you.